Hello everyone, so today we will be solving another question which is on Geek for Geeks, count inversions. So what we have to do in this question is that we have to find the total number of inversions that are possible in a given array. So let's discuss what exactly inversions are. So if any element in the starting of the array will become greater than any element in the forward array, then we will count that pair as an inversion. So 2 is greater than 4, not, it is not greater than 4, so this is not an inversion. So 2 is greater than 1, so it is an inversion. So we will count this pair as an inversion. So this, in this way we have to find the total number of inversions that are possible in a given array. Now what we will do, first we will discuss how to solve this question in a brute force method. So the brute force method will going to be two nested loops. We will start comparing 2 with 4, then 1, then 3 and 5. Then we will start with 4. We will start compare 4 with 1, then 3, then 5. In this way we will able to count the total number of inversions that are possible. We will initialize an inversion counter in the start of our main function, and then we will increment it as we hits the condition. If this element become greater than any element in the forward array, we will increment the inversion counter. Now but this approach will take omega of n square time complexity. What we want to solve this question in an efficient manner. So what we will going to be doing, we will uh, we will going to use merge sort algorithm. So if you haven't studied merge sort algorithm till yet, I would suggest that you should understand that algorithm first, then you will able to understand this question very easily. So let's discuss where we have to change our merge sort algorithm so that we can solve this question. So this you can draw if you have studied merge sort algorithm. Now what we have to do, as this will return the call to its parent and this will also return the call to its parent. Now what is happening, now we have to divide this array into two part and sort this and then merge it. So what we will do, that as we are doing our left calls and then merging it, uh, we will increase our inversion counter as we hit the condition if left part of the element will become greater than right part. So we will increment our counter. So here inversion become 1. Now the next condition come in the right part as well, then we will that we will going to handle in the right call, that we will increment our inversion in that side as well, but here it is not possible. Now uh, in the next condition, what is there, that we have to increment our inversion counter there as well, where one element is in the left part and another element is in the right part. So suppose this is two array that we have to merge, first sort and then merge. So we will start comparing. So initially I is at 2 and j is at 3, so we will compare 2 with 3. So 2 is greater than 3. So we will, what we will do, we will copy this element to our array, original array, then we will move our I to here. Now what will be happening is that 5 is greater than 3, so if we hits our condition that the first element is greater than the second element. So what we will do, we will increment our inversion counter, but by how much we have to increment, because if this element is smaller than 5, then it will be smaller than 5 and 8 as well. So we have to increment our counter by n1 minus I, because here inversion will be 2, so n1 minus I will going to be 3 minus 1, so inversion will going to be 2. So this is the only line that we will have to change in our code while doing our merging and counting function. So let's code it out. So first let return divide function that uh, we are passing our array starting index as 0 and ending index as n minus 1. Now what we will be doing, we will writing our divide function. So static log divide, and we are passing long array, we are passing our long L is a starting index and long R is an ending index. Now what we will do, we will copy the divide code, dividing function code from a merge sort algorithm. So let's copy it. So now we have what we have to change here. We just have to initialize an inversion counter to 0, and we have to update here as well. Inversion is equals to plus divide. This will be counting inversion in the left side, this will be counting inversion at the right side, and this will be counting inversion while one element which is greater than the next element is lying in the left subarray and another element lying in the right subarray. So merge inversion equals to plus minus this merge and count. Now in the end what we have to do, we have to return our inversion. So now what we have to do, now we have to write a merge and count function. So let's write it. Static long merge and count. We are taking array here as well. Then we are taking starting index as L, middle index as M, and ending index as R. Now we will copy the merge and count function code that we have done in merge sort. Okay, now what we have to change, we just have to change these data type because we have to return long as a data type, and we have to change this to long as well. New long, and we have to convert this int because indexing in array is int integer type. So as n2 and n1 are long. So after converting this, what we have to do, we have to convert this to int as well because L is long and we are adding long to int, so we have to convert that as well. And we have to convert this as well because this is also long as middle is long. Now what we have to do, we have to convert this also because L is long. Now after converting this, what we have to change, we just have to change this condition where left part is greater than the right part. So here this is the condition where here left part is smaller and here left part is greater. Let me comment it out. Left part is greater, so we will increment our counter. So let's first create counter. Long inversion is equals to 0. Now we will increment our inversion is equals to plus is equals to n1 minus I, as I have already discussed why we are incrementing by this much amount. Now what we have to change, I think code is looking fine. We have done inversion, returning divide. Here we also have to return the inversion, number of inversion. Okay, so let's try to run this code. Okay, where is the problem we are facing? Int m equals to, okay, we have to change long, this to long as well. Okay, so the test case has been accepted. So let's try to submit this code. So all the test case has been accepted. So I would say if you have depth understanding of merge sort, then you will able to understand this question very easily. So thank you. See you in the next video. Bye.